Hello everyone. Today we are going to learn about quantum numbers. Here, these are the numbers which describes about each electron in an atom. Suppose, let's take boron. It is an element with its atomic number 5. And its configuration is 1s2, 2s2 and 2p1. And in an orbital like this, each orbital, if it is s, like a 2 electrons, so orbital representation is like this. In this 1s2, 2s2 and 2px1, y1 and z1. In this, each electron, here arrow marks represents electrons. Here each electron information is given by the quantum numbers, and there are 3 quantum numbers here, N, L, M, and S is the one more quantum number which represents only spin values of electrons. Here the quantum numbers mainly gives information about the probability of finding electrons in the space around the nucleus, and one more is regarding energies of electrons in the subshells and shells. And the first quantum number is principal quantum number, and it is represented by letter N. In this, it carries maximum positive integer values. They are like 1, 2, 3, 4 and so on. Here first information given by principal quantum number is, it gives mainly about size and energy of the shells, main shells. Here, as the n value is increasing, size of the shells are also increasing like this. So as the value of n increases, the size of the shells increases. Here if you see 1, 2, 3, these are the n values, and when there is increasing the value of n, the size of the shell, these are called shells, and these are increasing. When these are increasing, that means size of the shells are increasing, the electrons present in the shells move far from the nucleus. It is nucleus, and these electrons are moving very far from the nucleus. So this information is given by the principal quantum number, and it is represented by letter N. Here for each value of n, and shells are named like this: K, L, M and N. K, L, M, and for the fourth shell it is N. Like this we have to name it for the n values 1, 2, 3, 4 like this. It gives mainly information about size and energy of the shells. Now one more quantum number is the second quantum number, that is Azimuthal quantum number. Azimuthal quantum number, and it is denoted by letter L. And this L carries mainly integer values for each given n value. Here L is equal to, it carries 0 to n minus 1 value for each given n value. For each given n value. So L is equal to 0 to n minus 1 values, and for each L value represents its subshell and the shape of the subshell in the space around the nucleus. And let us calculate the L values of each n value. L equal to n minus 1, just you apply the formula this, and for n is 1, if n is equal to 1, substitute n value, n is 1 and 1 minus 1 it is 0. L equal to, if n value is 2, 2 minus 1, there are two possibilities, two answers, 0 and 1, two values. And if n is 3, 3 minus 1, 0, 1, 2. Here 3 minus 1 means maximum value is 2 and minimum is 0. Total 3 values are possible. And if n is 4, 4 minus 1, you will be getting 0, 1, 2 and 3. That means 4 minus 1 is 3. 3 is the maximum value and 0 is the minimum value. Total number of values that are possible for the n is equal to 4 value means 0, 1, 2, 3. Total 4 values are possible for the 4n. Here each L value represents its subshell and the shape of subshell, and each L value carries one subshell. That is, if L is equal to 0, its subshell is S. If L is equal to 1, then its subshell is P. That means each L value is carrying one subshell. That is, for L equal to 0 it is S, and for L equal to 1 it is P, and if L equal to 2 its subshell is D, and L equal to 3 and then its subshell value is F. S, P, D, F are the name of the subshells, and L 0, 1, 2, 3 are the values of L. And here 1, 2, 3, 4 are the values of n. That means principal quantum number, and it is azimuthal quantum number. It gives only two informations, that is, one is size of the subshell and name of the subshell and shape of the subshell. That means around the nucleus, the space that is present, what is the shape of these subshells in the space that is present around the nucleus. Now you can write it as L equal to 0 means you got S, then you can write off 1S. Here you got 1, 1 minus 1 means 0, 1 is n value and 0 means it is S. And P means if I take n value 2, I am getting two values, that is 0 and 1. That means 0 means again S and 1 means again, here if you see L value is 1, then I should take P. So 2P. There are two values are possible, they are 2S and 2P for n equal to 2. If n is 3, there are three values are possible, 0, 1, 2, 3, and 0 indicates S, 1 indicate P and 2 indicates D, so that if n is 3, there are three values are possible for L, 0, 1, 2. If L value is 0, I should write S. If L is 1, then I should write P, 3P, and if L value is 2, then I should write 3D. If n is 4, then I have written here 4 minus 1 is 0, 1, 2, 3. There are four values are possible, that's why that is 0, 1, 2, 3. If L is 0, S. If 1 is there, then P. If L is 2, then it is D. And if L is 3, then it is F. So I can write 4S, 4P, 4D and 4F. 4S, 4p, 4d and 4f. Now again you count how many values are present in each n and each l value. Let's take l. If n is 1, 1 minus 1 is 0, then I got only one l value, that is 0. If l value is 0, its subshell name is S, then only one orientation, one is possible, that is 1s. If I take n is 2, then 2 minus 1, maximum value is 1, minimum is 0. There are two values are possible, that is 2s, 2p. That I have written here, 2s and 2p. Now if I take n value is 3, then 3 minus 1 is 2, maximum is 2 and minimum is 0. You will be getting three values, that are 0, 1, 2. That means 3s, 3p, 3d. And for the fourth shell same, 4 minus 1 is 3, then I got four values, 4s, 4p, 4d and 4f. The same thing here I wrote. Okay, this is about Azimuthal quantum number. We will learn about third quantum number, that is magnetic quantum number, and it is represented by letter m. This mainly gives information about the orientation of subshells in the space along x, y and z axis. In this, for given value of L, m value is equal to 2L plus 1 is the formula. It gives mainly again information about the orientations and the number of orbitals that are present in each subshell. Let us calculate by using this formula here. If L is 0, if L is 0, you know that it is S, and then m is equal to, just you apply this formula, 2L plus 1. Here in this L value, in this I am substituting L equal to 0. 0 plus 1. 2 into 0 is 0 plus 1 is equal to 1. In the same way, if L is 1, then its subshell is equal to P and M is equal to, just substitute the value of L here. L is 1, then in the place of L I wrote 1. 2 into 1 is 2 and then plus 1. 2 plus 1 is equal to 3. That means P subshell carries 3 orbitals with the orientations x, y and z along its xyz axis. Now if L is equal to 2, then M is equal to 2 bracket just L value. Apply this formula. L is 2, then apply here, and then 2 2s are 4, 4 plus this 1 is equal to 5. That indicates L equal to 2 means name of the shell is D. It gives 5 orbitals with the 5 orientations like this. Like this we can write or represent orbitals 1, 2, 3, 4, 5. Okay, like this we can also write for the F subshell, where we get 7 is the value of M, where 7 orientations are possible in the space around the nucleus. Now you know N is equal to 1 means L should be N minus 1. This is principal quantum number and this is Azimuthal quantum number. Third quantum number is 2L plus 1 is magnetic quantum number which can carry minus L, 0 and plus L values. Okay, this is principal quantum number which gives information about size and energy of the shell, and L gives information about shape and name of the subshells, and M gives about orientation of these subshells. Let us take one example. Right, take carbon with its atomic number 6, and I can write configuration like this: 1s2, 2s2, 2p2. Okay, in this, after writing 1s2, 2s2, 2p2, if I want to write any information about any one electron among these, just take 2s2. In this I should write information about these two electrons. Now use the quantum numbers. First, how many quantum numbers we have? N, L, M. Okay, now write N value. N is equal to, what is the N value here for the 2s2? This number indicates its N value. So N is equal to 2. Okay, directly they gave here 2s2, S here. Already we know L equal to 0 means S, and 1, 2, 3 means S, P, D, F. Okay, 0, 1, 2, 3, S, P, D, F are the names of subshells if L value is 0, 1, 2, 3 respectively. Here if it is S, then L value is 0, right? L equal to 0. And then M, what is the M value for this 2s2 electron? Right, if L equal to 0, M, just you have to apply the formula 2L plus 1, then you are getting only one value. That means L equal to 0 means M is also be 0, because minus L2 plus L, because L value is 0, 0 means minus 0 and plus 0 we can't write, only 0 means only one value, so we have to write it as 0. And for the next electron, the fourth quantum number, as I said, this gives only about a spin values of electrons, so I can write it as plus half for the first electron. S means one orbital with one electron up and the second electron is down. So for the upside electron plus half, for the next electron I can write the same quantum numbers with the different S value, that is S equal to minus half and this is S equal to plus half. Like this you should write the quantum numbers for this electrons. And the next example, if you want to write, if N equal to 2, L equal to, just take N equal to 3, L equal to 1 and S is equal to, M is equal to 1 plus 1 or minus 1 and S equal to plus half. Then you can directly represent N is 3, just write 3 here and then L equal to 1. If L value is 1, then subshell represents P, so 3P you should write. Now the M is plus 1 or minus 1, that while writing this no need of this, and directly you write plus half. Plus half means one electron with like this upside arrow. Then you should write like this 3P1. 3 represents its N value and P represents its L value and S represents its plus half. That's why I should take only one electron here. Got it? And M equal to, you will be getting plus half minus half, in between you will get 0. That means P carries total 3. M equal to 3 means it should be P only. Like this you should write all quantum numbers for any electron. With this I'll end my topic. Thank you.